Aaron, Apple is often held up as the quintessential example of a US company that kind of lost its way as regards, yes, it designs the products in Cupertino, but it makes most of the stuff in China. If Tim Cook was with us here right now, what advice would you have for him?
If you have shorter term windows that you're trying to optimize outcomes for, like quarterly shareholders, that doesn't help you actually, build something more meaningful, even though they are a multi-trillion-dollar company. So if you look back at like the early days of Apple, they got pushed actually to move stuff there. So it was a combined effort on on the government, um, from executives in other countries as well, trying to like build them a supply chain. Um, it's yeah, it's always more complex and nuanced than you would imagine it is, right? So um, building a supply chain as immense and complex as Apple's is not something that happens really quickly, right? So it's taken them 15, 20 years to get to this kind of a point. And it's still challenging for them to design something new, and pump it through, right? Like this process or this machine that they've built over there. And, Patrick McGee's book is really enlightening in a lot of ways around this because it's just, we've spent, not we, but Apple has spent, 100 Marshall Plans worth of, today's inflation adjusted dollars in building a workforce, factories, like the entire supply chain in China. And there were multiple forcing functions that pushed them in that direction. So, yeah, I mean, uh, my advice, would be starting like one thing at a time. How can you actually go about rebuilding that supply chain here? Where can you actually see um, a place where a competitive advantage can be built or rebuilt, domestically? And that's stuff that just doesn't happen instantaneously, throw like we've seen this happen and play out with other companies, namely like Intel and TSMC. You can't just like magically throw up a factory and expect it to do exactly what you wanted, right? Or like even build the factory in the first place. So we had to import people to even finish those things, and get the engineers over here. And TSMC's factory in Arizona, showed us that like you can actually have better yields. But there's just so many, there's so many different like factors that go into making that happen other than just like move the factory there.
Do you think there is a will to reindustrialize from the big companies like Apple or Intel, or do you think this is like the perfect moment for those hungry young startups that are kind of starting from first principles and don't have all that kind of technical or company debt to overtake them in all these different areas?
Yeah, I mean, I think what we're seeing now is that, um, the last, I don't know, call it like 100 years, and you can break it into like two pieces. Um, Probably not 100, maybe like 80. Uh, but where we're at right now is a unique moment, right? Because um, we're learning that globalization ultimately wasn't the unique force for good that we all thought it was going to be. And I think a lot of people put their faith into that, as a as a gamble, back in the 50s and 60s. But ultimately, um, it hasn't really played out the way that we thought it would, namely because building up one other superpower, we still haven't, conquered like human nature and the desire to, push each other around on the global stage. So there's basically like a much larger looming factor, which is that. And you know, if you basically turn one country into the factory of the world, they're obviously going to, you know, they're going to gain a lot of power and a lot of resources by doing that. um, and they're able to switch their industrial base, into dual use, and they have capability where we just don't, right? Like shipbuilding. So And with drones, they have a crazy advanced microelectronics supply chain. So it's pretty interesting that reversing that trend and people seeing the need to do that like today and now, it's been something that's been unfolding right for years. COVID made it even worse when supply chain became a household term, right? Like when you couldn't get toilet paper. So um yeah, I think it is a really interesting moment, and I do think that like young hungry founders, this is like a great moment for that kind of stuff, but it's also these are not like quick, easy wins. This is stuff where you really have to dig in. It's going to take decades to build, right? People have to kind of be in it for the long haul. But this is I do think the will is there, and like people understand that, and it's not even like, yeah, we need to rebuild everything China can do here. It's just that you need more than one China, right? Like they would rather see the world completely deindustrialized and dependent on them, and that can't happen. So we still have to stay in the game.
Say more about why America needs to reindustrialize. What breaks if we don't do it?
I mean, we've already seen a whole bunch of this stuff playing out, right? Like in defense world. So not being able to make 155 millimeter like artillery shells, and we sent them all to Ukraine, and now we can't produce any. Like we have no back stock. um, those would be depleted like very quickly, right? Shipbuilding obviously is another one. Um, drones. So like anywhere where you notice that there's this critical, deficiency basically, and we can't produce something. Um, ultimately, it comes down to like, do we have the capacity and do we have the trade skill necessary to like execute on it? Because you can, again, yeah, you can you can build all the factories you want, but if you don't actually have the skill to run and operate them, it doesn't matter. Yeah.
I think I've heard you talk about how the US, we literally forgot to build critical parts for, B-52 stealth bombers. Maybe for listeners that haven't heard this story, how do you even lose that knowledge? And if you lose that knowledge about something that seems really important, what else have we forgot to build?
Yeah, I mean, the story there is kind of interesting, but there was a heat exchanger in the B2, that was designed and engineered by somebody who doesn't exist anymore, and it could be a matter like we won't ever know the real truth of this, obviously, but like the engineering drawings, the blueprints, the schematics, right? Like the simulation data, who knows where that is? And even if you had it, would that help you like recreate this part that they needed? That's kind of the $1 million question there. And ultimately, when you lose that tribal knowledge, you ultimately like cannot make a widget or a product or something because you can't connect the instructions to the actual final output. So it's a fascinating problem, and like there's other really weird stuff, like pipes. Like we've the people that used to make like lead piping that is in a lot of um, municipal like water and sewer systems around America that has been replaced over 100 years, but like um, the way that we used to make those pipes, like nobody knows how to do that anymore. Not that you need to make lead pipes anymore, but like if we wanted to make them out of anything but like PVC, right? A lot of that kind of like just these weird crafts that because we don't use a material or a thing anymore, it's just gone, and so you can't like relearn how to do it all of a sudden. So it's uh and like my company, we're working on preserving tool and die making, and that's something that has reached dangerously critical levels on how much actual trade skill there is in this stuff here. And a lot of it where we built our company in Detroit is just kind of the leftover remnants of the automotive industry being there. So it's fascinating, right? Like the kind of like I don't know, the fingerprints that are left on society where you had to learn how to do something, and like who that skill was passed on to. Um, I still think that that's actually kind of the lifeblood of a lot of these problems ultimately.
Before we get into it, what Atomic Inc. is doing is actually just talk to me about all the different components of reindustrialization and manufacturing in America, because it's often talked about as this kind of big blob of this lump of labor fallacy. But within that, there's so much going on, right? As you said, there's the skilled labor and the tactic knowledge, there's energy, there's the factories themselves. So maybe just break it all down for us, and then what are the biggest problems to be solved over the next 10, 20 years?
Yeah, I mean, this it's going to be interesting to see how it comes together, and like we were talking about, not having to duplicate necessarily like everything that China does. Um, we're not necessarily trying to become autarkic, right? Like we don't need to make everything for ourselves. We can still have some level of globalization and trade. Like that's fine, obviously. It's just kind of like reselecting what level we want, and we're obviously going to be starting with things that are more critical in nature, and we're going to start with things that are likely higher value. But the interesting notion to this is that what people perceive as like low value manufacturing, right? Like making little low value commodity parts and things like that. Um, a lot of that stuff can actually be done uh, in a high tech way,
Hmm.
with higher margin, right? You can convert low skill commodity things into the opposite, basically, by kind of like reinventing the process. And I think um, all of the different buckets, right? Um, in something like this, in reindustrialization, you do have to like break it out, um, and ultimately, yeah, it's a huge full stack problem. You've got an actual demand, right? And this is the classic thing in manufacturing, is that you cannot just make a factory because there's zero demand there. And this is kind of what we're running into now. But um, you want the capability to make something when you need it. And that's ultimately a function of being able to create something that's like dual use, right? Like, is it, for defense? Is it for commercial? You're never really going to solve that until you've got magical sci-fi technology that where you just, like the Star Trek replicator or something. um, yeah, the layers of this are basically like demand and policy, kind of at the top, and policy obviously is going to drive all the incentive. Demand is still demand, no matter what. And then beyond that, you've got like the finance side of it, like who's actually going to finance these things, where in the stack are they going to finance it? Because traditionally, um, starting a factory, you need a bunch of capital to do that, and you can't just go walk into a bank and say, "I'm going to go make a factory. Can I get like 20 million bucks?" Like nobody is going to do that. So starting a factory in the first place is also a pretty hairy, like barrier to jump over, initially. So there are, there's a capital barrier to jump through, and then ultimately, you've got this huge list of like manufacturing and industrial processes that can be ripped apart and rebuilt, in this way that I'm talking about. It's just kind of like you got to go pick, the one that you want to go work on ultimately. I mean, it's in America, in terms of GDP, it's, a $14 trillion slice of our GDP. So if you can extract something out of that, right, and like improve it and 10x it, that's $1 billion business, like easily. This is also why it's impossible for somebody to like monopolize manufacturing, right? There's not going to be like a Google of manufacturing, not anytime soon anyway. That's just like, a multi-trillion-dollar company that can make anything, right? Like not even Tesla and SpaceX between them can do something like that. Elon would have to like shift his factories around in a massive way to be able to do something like that. But this is what people don't really understand about manufacturing. Like if you gave Elon a bunch of money, he could make a factory to make something really well, right? But the way Tesla and SpaceX are set up is that they've hyper optimized the production of like five things, right? Like Starship, and then 4 different car models basically. And they're going to do it with Optimus robots as well. So it kind of like goes to show you that that is possible, right? And then below all of these like thousands of manufacturing and industrial processes, you've got like the machines, and the raw materials and all this other stuff. So part of the value chain there is, where are we going to be getting all of our raw materials from? Are we going to start mining and refining again, right? Like we're seeing that now with rare earth magnets, and materials, like the government literally buying a stake in these companies to push them further and faster, should show everybody like how critical this actually is. And you can make an argument for even just like basic stuff, right? Like copper that's gonna happen to copper probably too. So and then like the actual machine tools, right? Like CNC machines, lathes, right? Like 3D printers that are industrial grade. This like we don't really make this stuff here at all. We don't like we rely on other countries to make all of our machine tools. There is a machine tool company in America, but like they rely still on like China for half of their bill of materials to make their machines. So yeah, it's crazy. So you have like all of that, and then the skill and the labor. So I know this is a lot of stuff, but this is kind of like what's rattling around in my brain at every given moment. But um, that layer cake is kind of the necessary constituent parts that you need to reindustrialize, right? Like, and then there's actually compute and other like the other stuff that people don't really think about, like the compute where AI is moving, right? Like new computational methods and things like that. Those unlock a lot of potential for the world of atoms, basically. And we haven't seen like a foundational model or an AI lab or an AI company that touches the physical world yet. And like you could argue that some of these like the humanoid robotics companies are that, but um, they can't do actual real manufacturing, right? Like translating a customer's CAD file into instructions that go through a CNC machine and cutting metal, to like 5 micron or below tolerance levels. So there's a ton of stuff that technology can really vastly improve, right? Like physics simulations and all these other things. So I do think that we're in a really exciting moment right now. So I know that was like ultra long winded, but
And we didn't even mention energy.
energy, yeah, it goes in, without, I mean, I guess it's just kind of a no brainer. Like before I started any of this, my PhD was in a field called power systems engineering, which is all of this basically. And it was a gamble on the electrical infrastructure of the United States needing to be transformed ultimately, right? Like with new sources of energy, with energy storage, like rethinking how the grid actually works and operates. And I think we're going to see something like that. Like most people that are focused on this problem are trying to just pump as much as they can into the grid with new sources of energy to power data centers. But there's insane bottlenecks everywhere, right? Like transformers are huge. Like grid scale transformers are going to be the next bottleneck, because 90% of them are basically at retirement age and nobody makes them. And they've got like a 3 to 5 year back order window on them, right? So we're not going to be replacing transformers in our grid anytime soon. So that's another easy $1 billion company for somebody to go start, like literally right now.
Do you think it's a case where all big, manufacturing, industrial processes, AI data centers, these other things, do you think that's all going off grid? And they'll just have their own solar plant or nuclear plant or whatever?
I mean, it's going to come. I think it's going to be a mess, honestly, because people like the companies want to move faster than the government will regulate, right? So, like this admin particularly is trying to slash red tape and regulation so that people can move quickly. But like even today, I still can't go develop, like a reactor that fits in a semi truck and then go park it outside my factory or my data center. Because what they're doing right now is they're using those like gas turbines, right, to power these data centers. And like, um, there's a sprint now, right, to like July 4th of next year to turn on the next first reactor from one of these startup companies. So I want to see them all split atoms, right? Like as fast as possible. But I also want them to be able to park their reactors outside of a data center. But, if you think about the public perspective of that, no, hardly anybody in the public probably wants that. They probably want the data centers to be as far away as possible and like get the nuclear, football in the truck away from my house. So I get it, right? Like, I don't know. It's going to be a mess, I think.
You talked about there being no Google of manufacturing. Do you think just by first of all, would it be possible for a startup in the next 5 years to create almost a manufacturing as a service factory where you can make 10,000 different things a day with humanoid robotics and AI and all that stuff? Do you think an idea like that is possible?
Not within the next 5 years, no.
Okay.
Um, I mean, the idea of uh, just like the complexity behind something like that, and I guess it kind of depends on what you're trying to duplicate. But when you go online and you see people complaining about how no American, manufacturer or like shop, like smaller shops, won't like take their weird order for just like one widget, like obviously they're not going to take your order like a Chinese factory will because nobody gives a shit. It's just like they're busy doing higher value work, and like a Chinese factory is probably just sitting empty, and like they'll throw your thing in there because most of their power, their infrastructure, their raw material, like has been subsidized by the government over the last, 25 years. So it's not really hard to understand like why that happens the way it does, right? People just treat China like it's an API for crap, basically. It's just like, oh, yeah, like go on WhatsApp and just text some random guy in a factory and like he'll send me my widget, like next week for like $1. I think it's if you can't actually understand why American shops and suppliers don't do that, like you should probably, reevaluate your understanding of how manufacturing works. But at the other end of that spectrum is like, why can't we do that? um, but it's there's a huge answer to why that is. But in general, it's just American suppliers and manufacturers have to survive on high margin work, otherwise they die. And the further you have this like big balance in the world where um, you know other industrial bases can like push the floor down on everything because they've been subsidized or they have cheap labor, right? Or they've become really good at something over time and they can do it for less ultimately, right? So if you push the floor down, that just kind of like tightens the margins that you can actually do here. Unless it's work that you cannot literally send overseas somewhere and it has to be done domestically, right? Which is a lot of defense stuff. So it's just super interesting how like the equilibrium of that ultimately works. And what we're trying to do is just like rebalance that equation by throwing tech at a problem that has an insane amount of human like labor and engineering that goes into every like customer project, and you cannot short circuit it basically. It doesn't matter how cheap your labor is. That's why I like the problem that we're working on because ultimately there's no way to short circuit it, so like we're the only way currently to do that.
Well, let's get into what Atomic is building. Tell our audience, maybe starting from the explain like on 5 level, and we'll work our way up.
Yeah, so um basically, to mass produce stuff, you have to like make a mold of a given widget, and it's like a snapshot of that thing in time, right? And you can build molds at all levels of complexity, right? So you can 3D print them out of plastic, or you can spend 1,000 hours of engineering one and then cut it out of steel, for production use in a factory somewhere. So there's a huge spectrum of how complex and expensive these things get. We operate on the far extreme of like production readiness, right? Like a single mold that we'll make is hundreds of thousands of dollars and typically takes months to design, simulate, engineer, and then ultimately like build it and put it together before it goes into a factory. So it is super interesting. And I said mass production, but typically the volume of production doesn't really matter a whole lot. I mean, it's largely used for producing a lot of a widget, right? But if you want the most reliable and consistent way to pump out one thing over and over and over again, it's to make a mold like this, right? Like at the highest spec that you can. So examples of lower volume where that happens are like the nose cone on a missile or something, right? Like those are molded. But it's not like Lockheed or Raytheon are making millions of missiles every year, thankfully. But they will engineer a mold, right? So that like when they need 500, they just go set it off and it pumps them out, and they come out to the exact spec that they need. So we've invented a lot of technology to avoid having to make a mold for something just because it takes so long, right? And it's very expensive to do this. So we're basically trying to like smash the cost curve and the time curve on being able to like make a mold for something. And then, when you have that power, that capability, what do you do with it? Do you just make molds for other people, or do you start making parts for them? Because ultimately, people just want parts,
Right.
right? Like they just want the part. They have to go through the mold making process. So, to your other question, like, can we have some kind of magical company or something that can produce thousands of different things, right? Like, I want to work towards that with this capability. It might take a little bit longer than 5 years to do it, but ultimately, I'd like it to become kind of like an AWS, right? Like what these cloud computing companies did for the internet. They took something where it used to be a very bespoke process to, go into a server and set it up and like build your company's infrastructure, on bare metal, and then put it in a data center somewhere connected to like the internet. And now Amazon is like, you click one thing and it launches a server and all of your code, and like you're done, which is sweet. So like, can't we just do that for physical crap too, and like be more like China in that way? I mean, like that's kind of how I imagine this. And it's really tough to do that because people design stuff without understanding how the factory works or what it can do. But you need to connect those together, right? And like going back to your original thing, like Apple separating design from production. Like the closer design and production are, the better ultimately. It's just that like production is a really hard problem, and it's not generally a flexible thing where it's right. Like you have a factory that just makes anything and then designs come into it. It doesn't work that way. You have to, you make a factory for something and then you can like, hyper optimize that. I want to see a world where that becomes a little bit, more flexible, basically.
If I was to walk into your factory, what would I be most surprised by?
Um, Probably maybe like the size of some of the machines that we need, right? Like, a mold, when you start building it, just starts out as a giant block of metal,
Hmm.
right? And it has to go through like different machines to ultimately like pare it down into, you know, more refined features, or when you chop up the metal into different components that go inside the mold. So yeah, the initial machine that we do like roughing operations on, which is like take the initial raw block of metal and then like beat it up, and cut it as fast as you can. So um, that machine is, I don't know, it's almost like 20 feet high. It's
Oh,
the
wow.
size of a house. It's insane. So I think like some of the machines are probably pretty striking.
Talk me through the kind of step-by-step process in creating one of these molds. Is it a customer comes to you with a problem, and then what do you do next, and then what's the end product, just step by step?
Yeah, I mean, generally speaking, you start with a CAD file, right? And the CAD file represents some part, and depending on who the customer is, they may or may not have an understanding of manufacturability, right? Like this idea and this concept of I should probably design this so that it can get made relatively easily, right? So the whole idea and concept of design for manufacturability, like DFM, is applying the constraints of the machines and like what they can do to a design, right? So like if you put certain angles or like features into a design that a CNC machine literally cannot make, then you have to use a different method of production to make that shape. Um, and all of these different factors will drive what type of production method that you actually need. So if the shape of it ultimately changes the production method because you cannot use like a CNC machine or a mold and you have to like 3D print it or cast it or something, um, those are things that like the customer needs to understand or be
Right.
educated on. So this is why the entire field of manufacturing is just so insane. I want to answer your question really simply, but it's hard for me because basically it's like, yeah, take a CAD file and then, somebody who knows how to make a mold looks at it. They go into CAD and they have another person who's on simulation software and they start designing. They design the mold. It's basically a reverse engineering problem or inverse engineering.
Mm,
It's like, here's a shape. And with all the tribal knowledge I know, I can construct the mold
right.
that's going to make this part. And it can be, it can be really complex or it could be simple. But ultimately, you have to know the mechanics of mold making, right, in general. And then you create an initial design. You have your simulation guy simulate it
Mm,
to understand, right, like the actual production properties. Like, where is this thing going to get hot? Is it going to have problems like opening and closing? You have to simulate that stuff. And ultimately, it's very trial and error driven because reality is different from what we can simulate. It's not always super accurate. So you basically end up spending a ton of time designing and simulating up front. The machining of the actual pieces of the mold is the smallest part.
right.
And then the back end is like trial and error. So it's like put it together, polish it, test it, and then you have to like error correct, when there's an issue. So it's just a really really intense process. And for like one given widget, it can take like 1,000 or more hours
Wow.
of human labor, to go end to end like that.
We often talk about this as, the bits versus atoms, bits to atom shift. But talking to you and other entrepreneurs, it seems like really where we're going is bits and atoms. There's a ton of, you just mentioned simulation, but you also mentioned a 24 high machine. So just talk to me about the trade off, maybe the difficulty of balancing those two.
Yeah, I mean, ultimately, we're an industrial society, right? Like, we're not going to get away from needing things. And ultimately, the argument that um, machines and our ability to use them and, like, sculpt matter to our will allows us to just, like, build more, right? It's Jevons paradox for just, like, the physical world. So, yeah, of course. It's definitely not one or the other. It's just more that like, you know, we're never we're never going to just like eat software for breakfast, right? Like software is not going to drive us to work every day or wherever. So like things still have to get made. It's just how. So I think that like, yeah, it's 100%, obviously like a hybrid. And it's something where as software gets more and more advanced and people are able to see, the impact of what technology can do for the physical world, like we're going to start seeing more and more of that, right? And like most of these skill sets don't exist at all.
Hmm.
um like the closest thing I can think of is doing applied AI, right? Like if it's robotics or self-driving cars, or robots in a factory doing some specific task, right? Like the more people that have this expertise of taking a physical system and optimizing it for like a task and then ultimately building like machine learning models and conventional compute algorithms to accomplish that, those are the skill sets that we need to be building, the fusion of these things.
So I have three young kids. What would you suggest? What's the top two or three things you'd suggest they go into? Study in their spare time.
Um, I mean, in their spare time.
Sure, I can help them.
I mean, this is interesting, right? So like, AI is really uniquely positioned to help kids like learn ultra complex stuff like way earlier than they normally would through primary school or something, right? So um, I think that like getting them jazzed up about stuff by exposing them to like, yeah, take them to an air show, take them to like, an aerospace museum or just every museum, right? Like, expose them to all this stuff and like show them big machines and like, that like really cool stuff like that, like I think this is the one thing that persists through adulthood with maybe with men, but like we're always in awe of a giant machine doing
Right.
something, right? It's like, if I could do that, that would be badass. So I think like, yeah, like jazzing kids up by exposing them to a bunch of this stuff and then like using AI to help communicate really complex concepts, is something really interesting. And then like the hands-on aspect of it, right? Like have them build stuff, even if it's out of like balsa wood, or like Lego Connects or something. Like help them make little machines, and like get more and more advanced. Like do rockets. Yeah, I mean, there's a ton of stuff, right? And like if you have the capacity to do it, like get 3D printers and CNC machines, like desktop versions,
Yeah.
in your garage or wherever your basement, and like build stuff with them. That's what I would do.
Do you think there's going to be a bull market in apprenticeships? Where I'm going with this is obviously there's 4-year college degree. It's been the thing that's been pushed on every kid for 40 years now. Is going get and it depends obviously, but is going and getting a 4-year engineering degree the way to reindustrialize America, or is it apprenticeships? Or talk to me about all that.
Well, yeah, I mean, ultimately, before somebody really picks what they do, they're gonna. Most people will pick like incentive over curiosity,
Right.
right? So, um, when I was going through undergrad, it was like working at a giant tech company was like the thing. It was like you work there for 7 years and you're an automatic millionaire.
Yeah.
And that was like, oh shit, that's actually kind of sweet, right? So, um, regardless of what you want to do, there's always going to be like incentive that outweighs that. So, I think that, another really interesting angle of reindustrialization is that, when you basically like upgrade, you know, the industrial base to this sci-fi future, you can actually pay people more, right? Like when productivity is multiplied by orders of magnitude. So, you might need less workers per factory, but like who cares? Factories become cheaper, they produce more, like build more factories.
Right.
Ultimately, it's just like it's not a fixed pie kind of thing. But where I'm going with all this is like if building like the new industrial base, right? Like in this like fusion of new skills and everything becomes the most prestigious thing to do, right? In the next like 20 years, that's amazing, right? Because now you'll have a whole wave of really, really smart people who are heavily incentivized to go into that. And all of those skills are still really important, right? Like being a good programmer and being a good engineer, like that's not going to go away anytime soon. Like if anything, AI will just augment your ability to do more. Right? Like it's yeah. So I think ultimately, um, those are still really valuable skill sets no matter what. Um, and yeah, I mean, I don't think that's going away anytime soon.
Aaron, and now we're coming up on time here, and I want to be respectful of your time. So I'll just a few quick questions to close. Who's the most impressive manufacturing company in the world?
Huh. I mean, I'm pausing, because I think of, a few companies, I guess, right, that like come to mind. So obviously, what Elon has done with his companies is pretty amazing. And then I also think about companies like Lego.
Mm.
Um, I don't know, people don't really think about this one, but like all of Lego's success and their ability to, you know, do what they've done was initially based on their skill in mold making.
Mm.
They built their entire empire on injection molding
Wow.
and being able to build molds really well. Um, in my mind, I think that's just like really fascinating that if you are hyper dominant in a skill, and you find a good application for it, like Lego is kind of the outcome there, right? It's like nobody could touch them. So I think that that's fascinating. I put them very high on my list, right? And then like Toyota, or even like Ford and GM and Chrysler, like the big three, they're fascinating because they have mastered like ultimate mass production, right? And there are really good examples of this that like happened over the last 10 years even, where people were all kind of like trying to blitz like new electric SUVs or something, right? Like I specifically remember this where Tesla announced the Cybertruck. Ford announced like the new Bronco they were going to come bring back, like resurrect from the 80s or whatever. Rivian was going to come out. Like we had all these cool new trucks that were going to come out, and guess who won? Ford, right? Like they got to mass production faster, and why do you think that is? Because they're really good at it. So, I think that like you can take a lot of these different aspects of how good you are at something and apply it. Um, Ultimately, that's kind of like what I respect the most, in terms of like being the most impressive manufacturing company. So they all have really amazing depth, and skill to them. And like Elon is the one figuring it out the fastest, like in real time. Even though it takes him like a few years at a time to do stuff, like the rate at which he's been able to accelerate manufacturing in different things, right? Like the Starship factory down in Texas is, once we actually finally get a look at that, it's going to be bananas. Like being able to make 1,000 of those a year is just mind blowing. So, um, I think he has kind of like, mastery of production, as kind of like his thing.
If you had to be max long one startup in the reindustrialization space, whether it's actually making something or whether it's like you guys making the molds or the tools, the machines that make the machines, who would it be?
And I can't pick myself, or
Well,
can I pick myself?
you're max long atomic already.
um, Man, it's a good question. Hmm.
Or you can build the Aaron reindustrialization ETF and mention three.
Well, I mean, yeah, there's gonna be a lot, right? Like I like oh man. I will say that I probably like Valor a lot because of their kind of like dual nature. Like I think they will probably split an atom first, but I also like the fact that they're going to produce a fossil fuel,
Yep.
right? Like I can use the byproduct of that to make plastics and stuff, which is kind of cool. Plus, use the energy at the same time, um, and then yeah, maybe Hadrian, maybe Rangeview, maybe like I'm more biased, or like Machina Labs, like I'm way more biased to the people that are making parts. So my ETF would be kind of like, energy, raw materials, and parts, basically. So like mining companies, energy companies, maybe energy companies that make raw materials too. And then people that are making parts. So that's like my ETF would be something like that.
And finally, just leave us with a dose of optimism. We talk about reindustrialization and often in a negative light, America has lost its way. But it seems like, you put on the Great Reindustrialization Conference recently. There was real energy in the room, real people building real stuff. So just leave us with a dose of optimism for the next decade of manufacturing in America.
Yeah, I mean, I think that, your very first opening question, right? Like, is this a time? Is the will here for it? Like, absolutely. And I think everybody sees this. I think it's a hugely bipartisan issue, right? Like, I think the last wide scale survey of this was like 85% of Americans would like to see more things built in America and manufactured here, which is incredible, right? Um, and I think that both political parties understand the value of this. So it's going to come down to, a handful of people, you know, pushing on this stuff while everybody else is like busting their ass basically. So um I'm really optimistic about, where things move. Um I'm really optimistic about, like, on the policy level where things will change as well to favor, domestic manufacturing and new trade skills being developed. Um and obviously, defense has a fire lit under its ass to do to do a lot of this stuff. So hopefully we see, right, like procurement changing and moving faster. We see um, applications going from concept to, production much faster. And then ultimately maybe new technologies arise out of this, right, that like can be used in a dual use way, so for commercial use and defense use also. I mean, like, I'm super intrigued by what the industrial base will look like in 10 years. So I think it'll be a much better world though. Yeah.
Aaron, thank you so much for your time. Where can people find out more about what you're doing, what Atomic is doing, and the reindustrialization movement?
Probably on my Twitter, or X or Twitter. So my handle is a physicist.
Awesome. Well, again, thank you so much for your time, and I guess I'll see you in Detroit next year.
Thanks, Steven. All right. Thanks a lot.